Bismillahirrahmanirrahim. Assalamu alaikum. Dear students, in the previous two lectures, we have discussed what is sodium hydroxide. Then we have discussed that how can we prepare sodium hydroxide by chloralkali process. In chloralkali process, we have discussed three cell processes which were diaphragm cell process, mercury cell process, and membrane cell process. We have discussed that in diaphragm cell there are two electrodes. One was cathode and the other one was anode, and the separation between these two electrodes were found by the asbestos fiber, which was known as asbestos diaphragm. Then we have discussed mercury cell process, in which we have discussed that electrodes are separated by the membrane or semi-permeable membrane, which was found by plastic materials or the polymeric material. Then we have discussed mercury cell process, in which cathode was formed of mercury and sodium dissolved in mercury, which formed sodium mercury amalgam, and after that, by the decomposition of sodium mercury amalgam, we have separated sodium and mercury. Then that sodium reacts with water and forms sodium hydroxide. Similarly, we also have discussed that why we prefer membrane cell process as compared to diaphragm cell process and mercury cell process. After that, we have discussed the reactions of sodium hydroxide, in which we have discussed the reaction of sodium hydroxide with acids, in which we have discussed that if sodium hydroxide reacts with acid, it will form salt and water, and we have said that that reaction is known as neutralization reaction. After that, we have discussed the reaction of sodium hydroxide with acid oxides, in which we have discussed reaction of sodium hydroxide with sulfur dioxide and hydrogen sulfide. After that, we have discussed reaction of metal with sodium hydroxide and metal oxides. Then we have discussed the reaction of sodium hydroxide with precipitants. That was our last reaction. Now here today we are going to discuss next reaction, which is known as sponification. Dear students, sponification is the hydrolysis of ester in the presence of base. Remember this definition. Now what he said, sodium hydroxide can be used for base driven hydrolysis of ester as in sponification. So dear students, this is the main definition which I have said, that sponification is a process in which hydrolysis of ester is done in the presence of base, amides and alkyl halide. However, the limited solubility of sodium hydroxide in organic solvents means that the more soluble potassium hydroxide is often preferred. He said that for the hydrolysis of ester, you have to use base, which is sodium hydroxide. But there is slight limitation, which is that sodium hydroxide is not completely soluble or not more soluble as compared to potassium hydroxide in organic solvents. If you want to use organic solvent, then you must use potassium hydroxide instead of sodium hydroxide. And the next point is, touching sodium hydroxide solution with the bare hands while not recommended produces slippery feelings. This happens because oils on the skin such as sebum are converted to soap. Sometimes for the solution of sodium hydroxide, the propylene glycol is being used, in which sodium hydroxide is more soluble. Despite solubility in propylene glycol, it is unlikely to replace water in sponification. Due to propylene glycol primary reaction with fat before reaction between sodium hydroxide and fat. What he said in this point? In this point, he said that you have noticed that if you touch the soap or if you touch the base, it will produce slippery touch. Like if you touch the soap and you feel. Why it happened? It happened because oil on your skin, which is sebum, converted into soap. When it is converted into soap and you feel slippery touch. These are the two main points in the sponification. In the next slide, we will discuss how this reaction occurred. Here we have discussed 2 points. First one was what is sponification, in which we have discussed that sponification is a process in which hydrolysis of ester is done in the presence of base. Then we have discussed that if you touch the base, then you feel slippery like soap. Why it happens? Because oil on your skin converted into soap, so it happened, you feel slippery touch. And then after these 2 points, we will discuss the reaction, how these oils are converted into soap. Dear students, as I have said that sponification is a process in which there is the hydrolysis of ester in the presence of base. Now I want to add some more words in my definition, which are: sponification is a process in which there is the hydrolysis of ester in the presence of base, which will give you glycerol and crude soap. Now in the reaction you can see that the fat, which is an ester, reacting with sodium hydroxide and producing glycerol, which is alcohol, and next crude soap. So our definition is here satisfied. So dear students, till now we have discussed 3 points. First one was hydrolysis. What is sponification? We have said that sponification is a process in which there is the hydrolysis of ester in the presence of base. As a result, it produces alcohol and glycerol. And also we have discussed in that for organic solvents, potassium hydroxide is more oftenly used. Then we have said that if you touch the base with naked hands or bared hand, then you feel slippery, which is due to the conversion of oil or fat into soap. And then at the end we have discussed sponification reaction, in which there is the reaction of fat with sodium hydroxide, which is producing glycerol and crude soap. Dear students, this is the main reaction for the sponification. And next we will discuss the applications of sodium hydroxide. Till now we have discussed the reactions, and then we have discussed different processes by which sodium hydroxide is produced. And before all of these, we have discussed what is sodium hydroxide and how it is produced by the chloralkali process. Dear students, after the discussion of what is sodium hydroxide and production of sodium hydroxide and reactions of sodium hydroxide, now it's turn for the application of sodium hydroxide. Here we will discuss where sodium hydroxide is being used and how sodium hydroxide is useful for the pharmaceutical industry and for the domestic uses. Now, the first point is sodium hydroxide as cleaning agent. Sodium hydroxide is widely accepted for cleaning, sanitizing, and strong chromatography media and system. The advantages of sodium hydroxide as a cleaning and sanitation agents are efficacy, low cost, ease of detection, removal, disposal. Dear students, sodium hydroxide is widely accepted as cleaning and sanitizing agent. It is also used in chromatography for the packing of column and for the washing of column. In HPLC, it is used for the washing of resins. If you use sodium hydroxide as a cleaning and sanitation agents, there will be different benefits. And the first one is it is more efficient. It has low cost. It is easily detected. Removal of sodium hydroxide is very easy, and disposal of sodium hydroxide is very easy. So, dear students, in this point we have discussed that sodium hydroxide is widely used as cleaning agent and sanitizing agent. It also being used in chromatography. Then we have discussed that if we use sodium hydroxide as a cleaning agent and as a sanitizing agent, there will be different benefits, where we have discussed first one was efficacy, then low cost because sodium hydroxide is cheaper. Then we have discussed that ease of detection. Detection of sodium hydroxide is very easy. Removal of sodium hydroxide is very easy. Then disposal of sodium hydroxide with impurities is very easy. Now the next point is sodium hydroxide has been shown to be effective in removing proteins and nucleic acids. It also effective for inactivating viruses, bacteria, yeast, fungi, endotoxins. Dear students, as sodium hydroxide is being used as cleaning agent, similarly sodium hydroxide is being used for the removal of proteins and nucleic acids. Sodium hydroxide is also being used for the deactivations of viruses. It deactivates viruses, it deactivates bacteria, yeast, fungi, and endotoxins. So till now we have discussed two main uses. First one was as a cleaning agent and sanitizing agent. Then for the removal of nucleic acid and proteins. Then we also have discussed that sodium hydroxide is being used for the inactivation of yeast, bacteria, endotoxins, fungi. Now the next point is, it is common practice in industrial manufacturing to save time by adding a salt such as sodium chloride to sodium hydroxide solution to combine cleaning with sanitization. For the combined effect, cleaning and sanitization, there is the mixture of sodium chloride and sodium hydroxide. Now the next use is sodium hydroxide used in pharmaceuticals. Here we will discuss how sodium hydroxide is being used in pharmaceutical industry. And the first point is, in the pharmaceutical industry, producers of biopharmaceuticals and biological products usually give attention to cleaning and cleaning validation of chromatographic reagents and multi-use purification systems. chromatographic regions must be disposed of or sufficiently cleaned to ensure reproducibility in subsequent cycles. Dear students, in industrial process or in pharmaceutical industry, we have used HPLC, where we used different resins for the chromatographic medium. Now, it is necessary to wash those resins, and for the washing, very efficient agent is sodium hydroxide, which remove all the impurities from the resins. If you not wash those resins, then you must have to replace those resins. So first use in the pharmaceutical industry of sodium hydroxide is that sodium hydroxide is being used for the washing of resins in the chromatography in pharmaceutical industry. Now the next point is, over the years, varied cleaning agents have been proposed. Once evaluating a new cleaning agent for resin, make sure it is compatible with system components as well. Destruction of O-rings and other column components by cleaning agent is a risk to process. Dear students, from many years, scientists or industrialists are trying different cleaning agents, and they are also preparing different cleaning agents. For a cleaning agent, it is very necessary. It will not disturb or it will not harm your resins. If it produce any kind of impurity or disturb your resin, then you will not use that kind of cleaning agent. So in this where we have discussed that in the pharmaceutical industry, sodium hydroxide is used as a cleaning agent, and then we have discussed that what things are necessary for a cleaning agent. As dear students, in the previous slide, we have discussed use of sodium hydroxide in pharmaceutical industry, and we have said that we use sodium hydroxide in a pharmaceutical industry for the cleaning of resin. Now here he is explaining why sodium hydroxide is being used for the cleaning of resins, why sodium hydroxide is a good cleaning agent for the resins. Now the first point is, for resins, the foremost cleaning agent is sodium hydroxide. Some reports indicate that heated sodium hydroxide is an excellent cleaning agent even without the heating. High concentration of sodium hydroxide require facility and equipment evaluation and use of safety equipment to protect workers. Now the next point is, sodium hydroxide is frequently used as an industrial cleaning agent, where it is often called as caustic. It is added to water, heated, and then used to clean process equipment, storage tanks, etc., etc. Dear students, in this point he said that sodium hydroxide is being used for the industry for cleaning process from many years. Industry, it is known as caustic. Now the question is, how we use sodium hydroxide as a cleaning agent. He said that sodium hydroxide is added in water, then it is heated. After that, it is used for the cleaning process. So if anyone asks how sodium hydroxide is being used as a cleaning agent in industry, then you will answer that first of all, you have to add sodium hydroxide in water, then you have to heat it. When it is heated or it is hot solution, then you will use sodium hydroxide as a cleaning agent. Now, what things are cleaned by the sodium hydroxides? Storage tanks, different equipments are being washed by the sodium hydroxide. It can dissolve grease, oils, fats, and protein-based deposits. It is also used for cleaning waste discharge pipes under sinks and drains in domestic properties. And the next point is, as a cleaning agent, sodium hydroxide saponifies fats and dissolves proteins. In general, it solubilizes precipitated proteins. Its hydrolyzing power is enhanced by the presence of chlorine. So students, when we were discussing the applications of sodium hydroxide in the start of our lecture, we have discussed that sodium hydroxide is being used in the chromatographic columns. Now here we will discuss how sodium hydroxide is being used in the chromatography columns. And our next point is sodium hydroxide in chromatography columns. And the first point is chromatography column become contaminated by a variety of proteins and non-protein species during a purification process. Dear students, as you know that chromatography is a purification or separation technique. In the biopharmaceutical industries, when you are using chromatography for the purification process, the chromatographic regions or the packing material of column become contaminated with many of proteins and non-protein parts. When it is contaminated with the non-proteins and proteins part, there will be different consequences of it, which we are going to discuss. The first one is increase the back pressure. It will increase the back pressure, due to which the speed of column becomes slowed down. Then loss of signal resolution. If your compound is impure, then you will not get sharp signal for your compound. When you will not get sharp signal for your compound, you will not identify which functional group is present in your compound or your product. So this is known as loss of resolution. Then the next point is alter the product yield. If you are expecting 80% or 70% your yield, then by the contamination of protein and non-protein parts or species, your yield will become less than 50%, which is very bad for your reaction or for your product. And the next one is medium discoloration. Different colored mediums were being used for the chromatography. If it will become contaminated, then discoloration happen, and we will not judge that how our separation is being occurred. Now the next point is common chromatographic contaminants include, there are different, as I have said earlier, there should be two contaminants. One is protein and second is non-protein part. Now we are going to discuss some common contaminants in chromatography. Here first one is residual proteins, nucleic acids, lipids, viruses, bacteria, yeast, fungi, prions, endotoxin, and metal ions. So dear students, these are different contaminants which were being attached with packing material, and altered our product yield, altered the resolution, increased the back pressure, and also done medium decoloration. So here, dear students, we have discussed that sodium hydroxide in column chromatography is being used to remove different contaminants like protein and non-proteins, in which we have discussed lipids, viruses, bacteria, yeast. Dear students, till now we have discussed the applications of sodium hydroxide, in which we have discussed the use of sodium hydroxide as a cleaning agent, as a sanitizing agent. Then we have discussed use of sodium hydroxide in pharmaceutical industry. After that, we have discussed the use of sodium hydroxide in column chromatography. Now we are going to discuss use of sodium hydroxide for the removal of protein. And the point is, sodium hydroxide has been shown to be effective in removing proteins and nucleic acids. It is also effective for inactivating most viruses, bacteria, yeast, and endotoxins. Dear students, he said in this point, sodium hydroxide is being used for the removal of proteins. Then he said that sodium hydroxide is also being used for the inactivation of viruses. It means for the deactivation of viruses, we can use sodium hydroxide. Then bacteria, yeast, and endotoxins. These three can also be inactivated by the use of sodium hydroxide. So, students, here 2 points are important. First one is removal of protein by sodium hydroxide. Then sodium hydroxide is also being used for the removal of, for the inactivation of different microbes like viruses, bacteria, yeast, and endotoxins. Dear students, till now we have discussed how sodium hydroxide is being used for the removal of proteins. Now we are going to discuss how we can remove nucleic acids by the use of sodium hydroxide. Nucleic acids can bind anion exchanges of chromatography equipments. 1 molar sodium hydroxide and 3 molar sodium chloride with a total contact time of 1 hour effectively removes radio-labeled calf thymus DNA from a weak anion exchanger. What it means? Dear students, you must know that in ion exchange chromatography, we use 2 types of ion exchanger. One is cation exchanger and the second one is anion exchanger. Now, our nucleic acid will bind with anion exchange regions. How we use or how we remove those nucleic acids? We can remove that nucleic acid by putting our region in solution of 1 molar sodium hydroxide and 3 molar sodium chloride for 1 hour. When we put it in that solution for 1 hour, nucleic acid will be removed. In this way, nucleic acid can be removed from chromatographic equipments. Now the next point is, since it is a bacteriostatic, it is recommended for the removal of bacteria from chromatography equipment. Sodium hydroxide should be added along with ethanol. Sodium hydroxide may not completely eliminate bacteria spore alone. In further good manufacturing process, required to complete the process. Till now, we have discussed sodium hydroxide is being used for the removal of protein. Then we have discussed that sodium hydroxide is being used for the removal of nucleic acid. How? When we use the 1 molar solution of sodium hydroxide and 3 molar solution of sodium chloride, then we can remove nucleic acid from chromatographic equipment. Now, he said that we can also use sodium hydroxide for the removal of bacteria in chromatography equipment with ethanol. And the next point is endotoxins are effectively removed by the use of sodium hydroxide as sanitizing agent. Endotoxins can be removed from chromatographic equipment by the using of sodium hydroxide as sanitizing agent. Next point is when sodium hydroxide used for the sanitization of chromatography media, the ability to withstand sanitizing conditions depend upon the following factors: functional groups, attachment chemistries, stability of base matrices to alkaline conditions. Now, there are some other applications of sodium hydroxide. Food use of sodium hydroxide include washing or chemical peeling of fruits and vegetables, chocolate and cocoa processing, caramel coloring production, soft drink processing, and thickening ice cream. Next application is olives are soaked in sodium hydroxide to soften them, while pretzel and German lay rolls are glazed with sodium hydroxide solution before baked to make them crisp. Sodium hydroxide has been used to straighten hair. And the last application is use of sodium hydroxide for the esterification and trans-esterification. Sodium hydroxide is traditionally used in soap making. It was made in 19th century for the hard surface rather than liquid products used because it was easier to store and transport. For manufacture of biodiesel, sodium hydroxide is used as a catalyst for the trans-esterification of methanol and triglycerides. This only works with anhydrous sodium hydroxide because combined with water, the fat would turn into soap, which would be tainted with methanol. Sodium hydroxide is used more often than potassium hydroxide because it is cheaper and a smaller quantity is needed. So, dear students, these were the applications of sodium hydroxide in which we have discussed sodium hydroxide can be used for the cleaning agent, for the sanitizing agent. Sodium hydroxide can be used in pharmaceutical industry. Sodium hydroxide can be used for the removal of protein, nucleic acid, endotoxin, and bacteria. We also discussed that sodium hydroxide can be used as a trans-esterification agent and esterification agent.